My name is Hany Fahim. I'm the founder and CEO of VM Farms and StaffThatIO. Today I'm going to be continuing a series of talks called Tales from the Ops Side. Today's talk is called My Favorite Errors, which is very apt seeing how we're in PagerDuty's office. And I guess to kick things off, I've got a confession to make, which is I love errors. Sounds absolutely ridiculous, but I've realized that in order to maintain my sanity, I must embrace the fact that things are going to break in our day-to-day lives. I've come to appreciate that the various errors and what they actually mean, and usually when a pager goes off, my first question anyway is, what is the error? Knowing what error messages mean can greatly speed up an investigation, which saves a lot of valuable time. And it usually hints at where to look at first. So to help illustrate this presentation, I'm going to be using this diagram of a standardized stack. Now, obviously, components may vary greatly. You may have external dependencies, various levels of redundancy, cache servers, etc. But this is a fairly standardized document to help explain the situation. And this also may be physical, it may be cloud-based, it could be container-based, but we've all seen this before. So like most of my talks, usually kicks off with a pager going off, waking us up. And my first action as a force of habit is, does the site ping? Try to figure out, does it ping at all? I usually use the fully qualified domain name because it may reveal problems higher up in the stack, just to see what's going on. And one type of error that you may come across is a non-existent or an expired domain. It's happened before, believe me. So imagining your client over here and something's wrong, so I'm going to try pinging the site to see what's going on. It's going to make an authoritative DNS lookup to find out to resolve that name, and then if it doesn't exist or it's expired, you're going to get an NX domain thrown right back to you, at which point your client is going to give this cannot resolve host error. I like this error very much because it reveals the problem right away. You know what the problem is, you pretty much can drop what you're doing and focus on the domain name. You may need to renew it, could be your authoritative DNS servers are down. This actual error can trick monitoring systems, and it's actually happened to us before where a customer's domain had expired and the monitoring system actually hung trying to resolve the host and never actually sent out a page, which is very frustrating, but we've actually since then fixed it, and as a follow-up we added domain expiring monitoring and caught a few others red-handed. Another error that you may have seen before is no route to host. This is where you're trying to make a connection, and if you imagine this fancy cloud over here is actually a bunch of interconnected nodes, what we call the web, and you're trying to ping the site, so to take a particular path on the internet, this is your route, and for whatever reason, let's say that one of the paths along the way are broken, and if you don't have any redundancy in there, or if all your redundant paths are down, you're going to get a nice no route to host error. This is like the equivalent of GPS or Waze, where you punch in an address and it tells you, I don't know how to get you there. I like this error very much because it tells you there's a routing problem right away, and it's somewhere between you and the site. I like to use the traceroute tool to help me pinpoint where the actual issue is, and it could be anywhere between your local ISP, the cloud provider, or anywhere else in between. And when this happens, you have no choice. You got to call upstream. You got to find out what's going on over there. This is a related error called time to live exceeded. So back to this diagram over here, imagining for whatever reason you've got a couple of nodes misbehaving and they start passing packets back and forth with each other in an endless loop. This is what they call a network loop. At some point your client is going to give up and say, I can't get you there, I'm going to throw you a time to live exceeded error. When you see this is pretty serious, usually again points to the network as the likely culprit, which is why I like it, it tells you right away. It could be due to misconfiguration, could be failed hardware, could even be an overload. And it's happened to us before. Back in the past, we used to have these pair of redundant firewalls. One got overloaded because a lot of traffic hit it, and it couldn't send a keep alive packet to its daughter pair. So then the other one picked up the traffic thinking the first one was down. It got overloaded, couldn't send a keep alive packet, and they basically just kept bouncing back and forth in an endless loop and threw this error. Again, it could be anywhere between your local ISP, cloud provider, or anywhere in between. And you got to use traceroute to find out what the problem is. Here's an example of one. If you try to traceroute it, and you'll notice over here, somewhere between hop 6 and 64, it's basically bouncing back and forth between this .56 and 51 IP, going back and forth endlessly over here. Most clients give up at 64 hops because, quite frankly, you don't need anything more than 64 hops to get anywhere on the internet. You can check what your local, if you run like a Unix-based system, you can run this command to find out what your hop limit is there. You've got connection reset by peer. I'm sure some of you have seen this before. Imagine you have an established connection, so this is where you've already done your TCP handshake with an end system over there, and you're starting to transmit data, you're having a good time, and for whatever reason, you get a reset packet thrown back from the end user over there, or sorry, the proxy. Your client is going to not understand what's going on and give you a connection reset by peer, and your peer, in this case, is the proxy. This is basically equivalent to you having a conversation with someone on the phone and they just hang up on you for whatever reason, they don't like you. Points me to the proxy as the culprit. That's why I like this error. It could be transient most of the time. It's a transient issue, like a process is restarting. You get this every now and then. If it's persistent, however, it could indicate that there's an overload occurring or some other load management kicking in. You gotta check the proxy logs. There's really not much you can do, if you can, to figure out what's going on. Here's one that I'm sure you've seen before called connection refused. This is where you have a proxy over here, and if you imagine you have a nice firewall with a little hole poked in to allow traffic to go through, in this case it's SSL traffic, and then you have a process that is bound to this particular port that is allowing traffic to go back and forth, and you have this nice established connection. If for whatever reason this process crashes, you're going to get a reset packet back, and your client's going to go, hey, I'm getting a connection refused over here when you're trying to establish a connection. This is the equivalent of you calling somebody, them picking up the phone and telling you to go away and hanging up right away. In this case, you know somebody is home, but they're not talking to you, so maybe you do that to a telemarketer, I don't know. I like it because the proxy is usually the culprit over here. Maybe do a down process, crash process, like out of memory, for example. You gotta check the proxy pretty much. Go to the source. Here's one I'm sure you've seen before called connection timed out. This is a TCP timeout. You're trying to talk to the proxy. So you start off trying to do a handshake. You send a SYN packet and you get nothing back. And then after a while you send another one, and then another and another. At some point, your client is going to give up and say, I don't know what's going on, I can't reach the other side, connection timed out over here. It's frustrating because this is basically you trying to call somebody and the phone just keeps ringing endlessly. You don't know if they're home, you don't know what's going on, they may be home, they're just ignoring you, or they're actually genuinely not home. I don't like this error. I hate it because the problem can be anywhere, really it can be. It could indicate an overload, misconfiguration of the firewall, the proxy, the app, the DB, could be rate limiting, network problem, local system problem, etc., etc. You basically just hope that there's a better error message somewhere else when you get this, because this is very unhelpful. Most of these errors I talked about are TCP errors. Usually, in our experience, they're pretty easy to diagnose and pretty easy to fix, usually. However, most errors that we come across are HTTP errors, and HTTP errors are higher up in the stack and are usually more complex to diagnose and resolve, generally. There's this nice tweet from Steve Losh a while ago summarizing nicely the HTTP status codes. You have your 100 series, hold on, 200, here you go, 300, go away, 400, you, the client, messed up, 500, I, the server, messed up. Very apt. Then dive into some of my favorites. You have your 400 series, like a 400, where the client is trying to send a request and you get a 400 bad request thrown by the proxy. I like this because it usually indicates that the client sent an invalid request, usually an empty request. It could indicate an interrupted connection, so the client may report connection reset by peer while the proxy reports a 400. It could be caused by request too large, so the opposite. Instead of sending no request, you send too big of a request. I know HA Proxy, for example, has an 8 kilobyte limit, which is way more than you need to send any kind of request, and you will get this error if that happens. Check the client side, usually to check the client to see if what the accompanying error is to kind of make sense of things. I'm going to quickly go through these ones that we all know. 401, which is basically you need credentials to get into this site over here. And then you have your 403 that says, I see your credentials, you're still not in. Got 402s, which I actually really like because it's payment required. Very blatant, right? Basically, you got to pay your bills when you get this error. Some providers, like Google Developers API, they use 402s to tell you that you're hitting some request limits in there. And I know that Shopify, for example, uses this to notify the world that you haven't paid your bills. Pretty blatant on their part. You got 404s, everybody knows that, right? Not found. I like this error because besides the very obvious, where something is not there, If it is unexpected, it may be due to file permission errors. Sometimes servers will throw a 404. If the requests are usually all from bots and are persistent, and these are good bots, not bad bots, it could indicate you have broken links on your site. And you may want to fix them pretty quickly because at some point the bots are going to stop crawling the site if you get too many, and then it's going to take a while for them to re-find you. If the logs are flooded with 404s, it could indicate a brute force attack. And I've actually seen some sites go down because of 404s. I'll give you an example. We had one client, e-commerce client, that was trying to make their 404 pages more user-friendly. So what they did is you try to hit a page that doesn't exist anymore, they try to do a lookup to give you related products of something that you're trying to look for. But because it's hitting the database, which is a very expensive call, and 404s are pretty easy to issue, it didn't take much to topple the entire infrastructure after a couple of 404s. Gotta be careful, right? You got 405s, method not allowed. And method here is HTTP verbs, like your gets and your puts. I like this error, because it tells you that the client is trying to reach the wrong endpoint, usually. You see this often on strict API endpoints where they're trying to control the HTTP verbs coming in. If it is unexpected, it could indicate the misconfiguration between the application server and the web server. Here's another one, a 408. Pretty simple, you're trying to establish connection with proxy. You make your connection, and after some time, you don't send a request in a reasonable amount of time, the proxy is going to hit a timeout and throw a 408 request timeout. Now, under normal circumstances, this is not a problem because browsers are pretty good at sending requests. That's what they're designed to do. But in recent years, we've actually seen an uptick in 408s across the internet. And the reason for this is actually due to optimization in modern browsers called predictors. Chrome has one called a TCP Preconnect predictor. And this happens when you load up Chrome, for example, it establishes a TCP connection with I think your top six most visited websites in anticipation that you're eventually going to hit the sites. But of course, what happens here, if you don't actually hit the site in a reasonable amount of time, it's going to time out and throw a 408, even if you never hit the site. And if you do eventually hit the site, because it's already served you content, you're going to get that 408 immediately thrown right back at you, even though you just visited the site, which is kind of confusing. Unlike other types of timeouts, which I really despise, I actually like this one because it usually tells you it's a client-side issue. As I mentioned, in recent years, we've seen this uptick because of these optimizations. And to avoid these, you usually have to tune the proxy to send empty responses for 408s. And here's Proxy's lovely workaround. You just basically hook in your 408s to dev null, which will send a completely empty response to clients. This is a hacky workaround in my opinion because it basically does it for all 408s. So if there's a legitimate one, you're not going to really be able to find out what's going on, but it's better than nothing. You got 499s, which is a non-standard Nginx specific error. In this case over here, imagining that for whatever reason, Nginx on this side detects the proxy hung up for whatever reason, it will log a 499 error in its own logs this way. Usually when you get this though, it is not alone. It's usually accompanied with another error, like a 504 gateway timeout on the proxy side. I don't really like this error because it's usually symptomatic. There's usually a real problem somewhere else. It's also Nginx specific, and it's likely coupled with that other error. It could indicate that the client clicks stop in their browser, so they're trying to load the site and they click stop. Nginx will log a 499. But like I mentioned, it could indicate a proxy timeout as well. It's not very helpful. You gotta keep looking to figure out what's going on. It's never alone. Here's another one, 418. Does anybody know what 418 is? I am a teapot. It is a great one. This is actually, I love it because it's not a real error, thank God. It was actually an April Fool's prank back in 1998 where they added it to the official HTTP spec. They also developed the Hypertext Coffee Pot Control Protocol, or HTTP. In 2017, actually, there was a group that called for the removal of the status code. Most browsers, by the way, accept the 418 and know how to process it. But in 2017, mainly led by the Node.js community, they tried to abolish this thing, saying it's ridiculous to have that. And they actually got pretty far until the internet had a massive uproar, and there was a huge backlash. They started the Save 408 hashtag along with this website over here, and they actually won. And now the 418 is immortalized in the HTTP status code club forever. So some juicy stuff now, getting to the 500 errors. You got 502s, which is bad gateway. In this case, for whatever reason, Nginx decided to terminate its connection or send an empty response or or a bad response in whatever reason. The proxy will log a 502 and throw that back to the client. The same thing can actually happen between the app server and Nginx server. If this happens, the app server sends an empty response, the Nginx is going to generate that error, and that's going to bubble all the way up to the user. You're going to usually see things in your logs like connection prematurely closed your connection, or connection refused, even another standard TCP error you may find in your logs there. I like it because it indicates a problem with Nginx, which is unlikely. The more likely scenario, it's probably the application. You see this when applications hard crash, like they run out of memory or there's some unexpected error and they just exit quickly. Usually if that exits quickly, there may be some exploit happening, so you should also check your logs to see if there's some funny business going on. You see this also with application server timeouts, like if you're running Python, you have Gunicorn. Gunicorn has an internal timeout set. If you hit that timeout, it's just going to terminate the connection without sending anything back, and your logs are going to show this error. Check the application logs, and usually the kernel as well to see if it was out of memory. 503s, very sane one. You put your backend servers into maintenance mode because let's say you're running some large database migration. If you have no servers to serve up content, it's going to throw 503s to any request coming through. Very, very sane one because it's usually manually triggered by a human most of the time. Could also be due to an overload. Let's say you set up max connections and you don't have any more slots to serve up your clients. You're going to get this as well. Usually it's transient, so you don't have to worry it's going to come back, hopefully. 504s. For whatever reason, Nginx decides to take too long to respond. The proxy is going to hit a timeout, and it's going to say, throw back to the user a gateway timeout. The gateway in this case is the Nginx server. The same thing can actually happen between the app and Nginx, just like the previous error. What's really funny about this one over here is that the app server can actually record a 200 OK error in its own logs, which kind of confuses things. In fact, it's entirely possible that the proxy records a 504 gateway timeout, Nginx records a 499 client close request, and the app server records a 200 OK for the same request. For one request, you get 3 different status codes going on, which is incredibly confusing. A little trick that I learned to kind of bypass this is that you set your timeout values in ever-increasing values the higher up in the stack you go. For example, if you want to say that no request should take longer than 30 seconds, what you do is you start at the app server, set that at 30 seconds, and then Nginx, you set that at, say, 31 or whatever the next smallest increment is, and the proxy would have 32. This way, if a timeout, real timeout occurs, all your error status codes are all going to line up this way, because it's going to originate usually at the app server, and everything else will pick it up. I hate this error very much, because it's very confusing. Usually, especially if the app logs are clean. Could be due to mismatched timeouts in the stack, like I mentioned, and usually, like most other timeouts, the true issue may be hidden, and you got to go digging elsewhere. So we've arrived at my favorite all-time error, which are 500 errors. I love 500 errors. Why do I love them? Because they always come from the app server. No matter what, they're coming from the app server, nowhere else. It's beautiful. And usually because they're coming from app servers, you get a nice stack trace, and you usually get a nice helpful error message like too many connections, which tells you it's a database problem. Go search your database logs, find out what's going on. It could be even standard errors like connection refused or connection timed out. Because they're coming in the form of a 500, this tells you that the problem is elsewhere in the stack. Could be an external dependency. Let's say you're hitting an external API and they're taking too long. Your app server is going to record a 500 and immediately tells you it's probably somebody else's problem. Could actually even be another 500 type error, like a 504 gateway timeout wrapped in a 500. Again, this usually tells you that if somebody else is throwing you this error and it's coming up in a 500. I love it. Every time I see this error, I can breathe a sigh of relief because I know where to look, I know where the problem is, and I'm going to get very helpful information. Always comes from the application. A little asterisk, you may get it higher up in the stack, especially if you use things like custom modules like Lua processing, because Lua itself would probably be an application. So you get a 500 from there, but if you're normal, most of the time is going to be an application from the app server itself. And even generic errors, like I mentioned, are more helpful when they come in the form of 500. I got some honorable mentions. Could not obtain random bytes. Very helpful. This is actually an open SSH error. It tells you that you've run out of entropy. The topic of entropy is an entire talk in of itself, very complicated, and it's kind of ironic that computers need chaos in order to function properly. Operation not permitted. This is a kernel level error. It tells you that some ACL is blocking you, preventing you from doing what you're trying to do. You got socket timeout after 10 seconds. This is a NAJA specific error, and most of the time when people see this, they think network problem because it's got the word socket in there. But actually, it's much simpler than that. It just means that something took more than 10 seconds to respond like a probe. I don't know why they chose socket. It made life very confusing. You got segmentation faults. Usually that means something really bad happened. Just go home at that point. Not much to do. Here's my all-time least favorite error. It's no error. When you know something is wrong, but there's absolutely no error to be reported. It's terrible. I'll give you a story. One of our clients on a nice Saturday morning calls us and tells us that their site is down, which is funny because there's absolutely no errors on our side. The alerts, the monitoring system is clean, there's no pages going off, everything is reporting green across the board. Okay, I think maybe it's the client. Try to load up the site myself, punch it into my browser, and it works. No problems there. So jump onto the proxy, let's see if we see any errors and some of the app servers as well. The logs are clean. Everything is reporting perfectly fine, and you tail the logs and I can see my requests coming through. But the client was pretty adamant that there was a problem. So okay, you have to indulge them. Gotta ask some questions then. Why is it working for some, like me, and not for others, like you? Called other team members on the team and asked them, hey, can you try visiting this site and see what you get? And it works for them too. All right, more and more convincing that it's something going on. Maybe there's a routing issue. However, someone took a look at the server graphs and noticed this lovely pattern over here. Right around 7 p.m., traffic took an absolute nosedive. And this is a high traffic website over here as well. This was actually the first and, until this point, the only indication that there's actually a problem on our side, besides the client telling us there's something wrong. So I got more questions, right? No errors whatsoever. Why does it work for some and not for others? One of the team members decided to load the site up on their phone, and they've actually noticed that it didn't render on their phone. And I was actually able to confirm the same thing. So I pull up my phone and I try to hit the site, and it's just sitting there spinning endlessly. No error message, nothing comes up on the browser whatsoever, it just sits there holding it on and spinning endlessly, which is very strange. I thought, okay, it's not working on my cell phone, maybe there's a routing problem, right? Trying to confirm it. My cell phone is going through the cellular network and my laptop is going through the Wi-Fi. It's got to be a routing problem, right? Except my phone was on Wi-Fi as well, so it's going through the same network. This is confusing. Same network, different clients, different results. What is the pattern over here? Scratching your head, right? Somebody then mentioned that, hey, our laptops, go through, automatically connect to our VPN. So all the traffic, especially the ones that we force routes, go through our VPN. Interesting, which means the traffic actually kind of looked like this. It was going over the internet to the VPN and hitting the site in the same data center. And that's an important point because it's going through the same data center, which means it takes the same route to get to the endpoint, which rules out a routing problem. Okay, turn off the VPN, and lo and behold, the site doesn't work. Finally, able to replicate it on the laptop. So again, where's the error? Why is it just hanging? It doesn't make any sense at this point. Gotta get deeper into the stack to figure out what's going on. Busted out Telnet, one of my favorite tools to try to figure out what's happening here and trying to Telnet to the site. And I get the standard reply back. And there's a bunch of interesting information already. First of all, the IP is correct. We have verified that. So it's connecting to the right person. It's connecting to the right IP. It's not, there isn't a DNS problem. This is also really interesting, the fact that it says connected to the broken site, which means it did a TCP handshake with somebody and established a connection. All right, so I'm at the endpoint, try to issue a standard request, like a GET request, like a browser would do, and nothing. No response, not even a timeout. It just kind of sits there hanging indefinitely, just like the browser and on the phone. All right, I have some questions here. Is the request actually making it to the proxy? So bust out this, go on the proxy and bust out this fancy looking TCP dump command, which is basically a really fancy way of sniffing traffic to find out what's going on. And you get this normal reply, and under normal circumstances, you get output that looks like this. And this part that I highlighted over here, you can see is actually a standard request that you get that when a browser issues a request. So you'd see this under normal circumstances. However, there was absolutely nothing. When we issued the manual request, nothing came through on the other side. Nothing at all. So who the heck am I talking to? Where is my manual request? I should at least see that. I should at least see standard TCP packets, like I did a handshake, right? I should see SYN, SYNAC, and ACK for established connections, but I didn't get that either. So who am I talking to? I'm talking to somebody who's pretending to be my client because I'm getting that IP. Something very fishy. So phone upstream, because we can't figure it out, and ask them, hey, is there any reported issues on your end? Are you seeing anything weird? And they're like, nope, nothing unusual. Except for that non-service impacting maintenance that we're running right now. It's like, all right, non-service impacting maintenance. Why don't you talk some more about that and tell me what's going on? Well, it turns out their upstream was installing some DDoS mitigation hardware on the network, which does not sound non-service impacting. They're like, no, it's definitely non-service impacting. It's configured in passive mode, so trust us on this. All right, well, can we get some confirmation about this? What was happening is the upstream who controls the last node over there, they're configuring this new device and routing all the traffic, but it was configured in passive mode, which means it should just pass traffic blindly and no issues there. Sounds reasonable. And then you hear on the phone, oops. It's like, all right, what's oops? Well, actually, passive mode is actually pretty active. Instead of configuring it to true passive mode, it was set to active, but with really, really high thresholds. And guess what? Our customer was crossing these thresholds. Okay, sounds okay, but I have some questions, like why does it just hang? What kind of DDoS device, when it hits a threshold, just hangs the connection? I don't need a DDoS device to do that. I can do that myself. Well, this device was brand new, and it didn't have any rules configured to handle these threshold breaches. And by default, when it crosses the threshold without any rules, it just holds onto the connection indefinitely. Okay, so why was passive mode actually active mode? Well, it's a last-minute decision by the network engineering team. You see, passive mode would completely disable the device, so they wouldn't get anything like even logs to figure out how to tune the device, and they actually wanted to observe what the activity looked like to be able to tune it accordingly, which actually sounds kind of reasonable, except for the fact that they did it last minute and didn't inform anybody about this and actually turned this into an outage. So we had some lessons and follow-up after this incident. We turned on monitoring side timeouts. Up until that point, we had completely disabled it because we wanted to see what clients see. I didn't want my monitoring system throwing some of its own timeouts and messing up your end results. You want to see what clients would see. But at the end, we decided, all right, we're going to turn those on, but set them to really high thresholds because at the end of the day, getting a late page is better than no page at all. I wanted to get notified of any and all maintenance events going forward because I can't trust these people. But this actually turned out to be a bit of a fight because they were saying they do this kind of maintenance, non-service impacting maintenance dozens of times a day. So you're going to be getting dozens of messages if we actually did this, and it would become white noise. And I actually agree with them because then I won't be able to tell which is actually legitimate at this point. We ended up negotiating and settling on anything that is considered major and putting a definition on that should be notified. And things like a DDoS device is now considered major. I learned that no errors are no fun at all. You got to keep looking when you have none. Timeouts are absolutely evil, but they are necessary. And if I were to rank them, I'd say that no error is worse than timeout errors, which is worse than any other errors out there. I got a quick little note here about StaffThatIO, which is a new division of my company, VM Farms. We're starting this new initiative for continuous stack modernization. So a lot of companies, they have a wish list of things that they want to do, new technologies they want to adopt, but they don't have the time, the resources to commit to it. Basically, we do one-off projects to kind of nudge you a little bit forward into the modernization era. Things like if you want to mess around with Kubernetes, containerization, infrastructure as code, you want to migrate to the cloud, which is a big project in and of itself. You want to do some you want to move from self-hosted to managed services, like let's say you want to use RDS or ELK on Amazon, scaling, application performance monitoring, anything you can think of. This list is endless and very flexible. You basically, what you get out of it is a full access to DevOps team on our side through Slack. You get full documentation provided, which you get to keep, and guidance along the way. And we also, for those that want to do this on a more regular basis, we've got subscription models available too, so you can kind of keep up to date continuously. We got our shirts if you guys want to come and talk about this after. And that's everything I got. Thank you very much. Anybody got questions?
That was actually awesome.
Thank you.
I was like, I don't want to say actually awesome. I was like, yo, that was fun. With respect to errors, status codes, I mean, I had something to ask about the 408, but it's a little complicated. How about, are there any, do you know of any kind of recent RFCs? Are there any status codes that are in consideration right now? Because I know with sort of like browsers and the way how they've become fairly powerful and whatnot, in comparison to, say, the early days of status code development. Do you know of any new ones coming down the pipe?
Very good question. When I was doing the research for this, I went on the Wikipedia page of HTTP status codes, and it is massive. There's a huge list of so many obscure status codes that only one company in the world uses for one very specific reason. I didn't keep on track of any ones coming out, but they're being released like crazy. And if you're like Nginx, you're like, forget about doing an RFC. We're just going to create our own and create 499. Go to the end of the 499 of the 400 range and use our own. I don't know of any that are doing that, but there are tons and tons and tons of very obscure ones that if you come across, you're pretty much going to have to look it up to figure out what it is. Yeah.
Just on a personal note, you mentioned RFCs. Got any favorite ones?
RFCs. Come on, you mentioned the teapot one, right?
Yeah.
That's a pretty fun one. If you actually read it, it's quite hilarious. It's got an incredibly serious tone to it, but the underlying thing is about coffee, and you got to make sure that when you're trying to talk to a coffee pot, that there's actually not a teapot in there. That one is my personal favorite. That's why it's in here. Yeah. I should mention as well, these slides can be made available if anyone's interested. It's could be useful as a reference if you ever come across one of these to help diagnose it. So you can come talk to me and I can share those with you as well. I do have it. I think it's on share slide. I think so. If you come, I'll pass along the link. Any other questions? You all know your
Someone made a comment earlier. It's a pretty funny exercise to map the Toronto highways to the 400 series towers. See what it means?
401, you shall not pass.
Yeah. 404, 403.
Gone.
Gone.
Thank you so much, Hany.
Thank you.